So this video is on an introduction to equilibrium. It is notes for just college prep chemistry. So this whole new unit is all about equilibrium, and that starts with having reversible reactions. So the conversion of reactants to products and the conversion from products to reactants. So reversible just means it's going to go forward and backwards as a reaction, and both of these things are going to occur simultaneously. So it's going back and forth at the exact same time. So a quick example of that would be nitrogen reacting with hydrogen. Okay, normally what we've seen is just this one-way arrow pointing forward, but now we're going to have double-sided arrows pointing both forwards and backwards. And this is going to make ammonia, and the equation is obviously balanced, so it can go forward or backward. Another way they sometimes write this new yield sign is kind of with like half arrows frontwards and backwards. So sometimes one side of the arrow or the reactants will really push towards the product, and sometimes the products will push towards the reactants. So sometimes this is shown with a larger arrow on one side. You can kind of think of this like two kids fighting and pushing against each other, but one kid is bigger, so he kind of pushes a little bit harder. So what is chemical equilibrium? This is when the rates of the forward and the reverse reactions are equal. And it's very important with these that it's the rate of the reaction. So that is how fast are the reactants becoming products and how fast are the products becoming reactants. People often get really confused by this. It is not the amount of concentration. So it is not adding more of something. It's not saying that more of something is being made. It just means that one of them is going the same rate as the other. When we see this, there will be no net change. So when you're looking at it, you're always going to end up with the same amount of reactants and products. The reaction will always keep happening. They actually never stop reacting. We just can't see this actual finishing. So they're always going forwards and backwards. We just say that it ends up at equilibrium when this rate is the same and when you no longer see that net change. So just note that it is still going and changing. So now I want to look at a physical example of an equilibrium reaction happening. So this is just a demonstration. They have some water and they just add some sugar to it. So what happens is that the sugar will actually react with the air, but it takes a very long time. So he is going to add a catalyst, and we remember a catalyst is what speeds up a reaction. So this is potassium hydroxide he's adding, and that's just going to help the sugar react with the air more quickly. We can't actually see this happening because the reactants are just invisible to our naked eye, or they look clear or white. So he's going to add an indicator, which is methylene blue, and methylene blue is blue in the presence of oxygen. Okay, so he's going to cap it to trap the oxygen inside his flask. Okay, so it is blue right now. That means that there is a lot of oxygen present. Okay. So while we let this sit and wait, the sugar is going to be reacting with the air, and what that's going to be doing is pushing the reaction forward. Okay, so it's slowly moving forward, and we can see it slowly turns back clear. What happens when you shake it, you're adding a bunch of more bubbles, which is actually air, into the mixture. So that air that was trapped in the top, he's adding in the mixture when he stirs it. So now when he stirred it, that pushed the reaction back towards the left, towards the products. So this is just an example of equilibrium. A reaction can move forward and then backwards, and then if we let it sit a little bit, now it's going to move forward again. This is equilibrium. Okay, a reaction that can move forward and backward. In this case, we can see that the reaction with oxygen is more favored. That's why it keeps going to the clear side of things. When he shakes that, he's pushing it to the reactants, but it really wants to be products. So this would be a case where there's a larger arrow pointing to the right side. All right, guys, this is just a quick video on equilibrium. And that is all for today. Just answer the couple questions on this page. Awesome.